All right, so the warm-up question says, based on the free body diagram below, what is the acceleration of this object if it has a mass of 5 kilograms? And then the follow-up to that is, how will its acceleration compare if its mass is 3 times more? So let's go ahead and solve the first part first, number 1. Obviously, there's information given to us in the question, so we can label that, but there's only one value in the question itself, and that is the mass is 5 kilograms. The other information that we're given is in the free body diagram. There are 2 different forces shown in this free body diagram, and we need to use those to figure out what our total net force is that is acting on this object, because its acceleration will be due to the net force acting on it. If you have an object with 20 newtons acting to the right and 7 newtons to the left, then you're going to end up subtracting. Because those vectors are pointing in opposite directions, when you're adding them together, one of them is positive and one of them is negative. So in this case, to the right would be positive, that would be positive 20. And to the left, that ends up being negative 7. So when you add them, you're really adding 20 and negative 7, or subtracting 20 minus 7, which would give you a net force of 13 newtons to the right, or positive 13 newtons. So you have to use that free body diagram to get the net force that's acting on the object. The mass is in the question, and the unknown that we're looking for is, what is the acceleration? The equation here, we only have one equation right now that has force in it, and that's that F equals ma, or more precisely F net equals ma. And so we can substitute into that formula. Again, when you get to the substitution step, please double check your units. We look good. We have kilograms and newtons. That's what we want. So there's not a conversion needed. We can plug them in as is. 13 equals 5 times A. If I want to solve for A, I need to get it by itself, which means I need to divide both sides by 5. And that's what goes into your calculator. 13 divided by 5, which gives us an acceleration of positive 2.6 meters per second, or you can write that unit as meters per second squared. But it will be to the right because your acceleration is always in the same direction as your net force. All right, that's number 1. Number 2 asks us to talk about what the acceleration would look like if the object had 3 times as much mass. And yes, you could go back and resolve this with 3 times the mass and put 15 kilograms in there instead. Or you could just think about what we've already talked about, or back to the equation for this. If you want to determine the relationship that mass has on acceleration, we really ought to rearrange our equation and set it equal to acceleration. If we want to know what the effect is on acceleration, it's easier to see if we write acceleration is F net over m, which I get just by dividing both sides by m. And when you do that, you can see that it's inversely proportional, because when you change the mass, it's in the denominator. So if you make that mass 3 times as much, you're dividing by 3 times as much mass, and you're going to get 1/3 the amount of acceleration. So you can go back to the equation to see what the relationship will be, or of course we already talked about this in our notes. We said that mass and acceleration are inversely proportional. You should have that written down already. Or even think back to your RA. You tested this. You tested what happened as you increased the mass of the fan cart, and as you increased the mass of the fan cart, you should have noticed that the acceleration was smaller. So again, please make sure that you have answered both of these questions in the warm-up, and there's also a couple check-in questions there where you can talk about how you feel about the stuff that you've learned so far. Hopefully comfortable. If not, then that is a sign to you that you have some things that you might want to look at before you come to class tomorrow, and definitely before you come to class on Friday, because you have a quiz on Friday. All right, so moving on from today's warm-up, as I said, we have notes, but it's not so much notes as a couple more practice problems. When we were doing the practice problems yesterday in class, we were looking at problems that had multiple steps. These do as well. Okay, I have a question up here right now that you're going to see in just a minute requires multiple steps. So we just wanted to go through a couple more examples so that you have them to look at, because your assignment today also includes questions that have multiple steps. and so will your assignment tomorrow, and so will your quiz and your test. This one says a boy on a sled, their combined mass is 93 kilograms, moves across the snow at 4.1 meters per second and comes to a stop after 7.5 seconds. What is the frictional force that brings him to rest? Again, when you read the question, please start by labeling your givens. The first number that I have labeled is my initial velocity because it says he's moving at 4.1 meters per second and comes to a stop. So I also know my final velocity is 0. I know a time, 7.5 seconds, and I actually skipped over it. The first number in the question was a mass. Okay, so I have all of these things given to me in the question. Initial velocity, final velocity, time, mass. The unknown that we're looking for is force. If I think back to my equations, I know that I only have one equation for force, F equals ma. But if I look at my givens, I can't use that equation because I don't have a. When I look at that given information, I have VI, VF, T, and M. So I have the M, but I need the acceleration in order to find F. So the first thing I'm going to have to do is actually solve for acceleration, and then I can go back and find force. And if I look at my variables that I've been given, I can solve for acceleration using one of my kinematic equations. I already know I can't use F equals ma, I don't know force. So we have to go back to these. We have got 4 of them. We're looking for one that we can use when we know VI, VF, and T while we're looking for A, and that's going to be equation A on my screen. Equation A says VF equals VI plus A times T. Those are the variables that I have labeled and the one I'm looking for. So that's what we're going to substitute into. Again, when you do your substitution step, double check your units first. These look good. We have meters per second for our velocities, and we have seconds for our time, so that's good. When we plug in, it looks like this. 0 equals 4.1 plus A times 7.5. Again, algebraically speaking, some of you are running into problems here because you're trying to add 4.1 and 7.5A, and you can't. Those are not like terms. Instead, you need to subtract one of those terms to the other side of the equation. I'm going to go ahead and subtract 4.1 from both sides, which leaves me with this. Negative 4.1 equals 7.5a, and now I can solve for a by dividing both sides by 7.5. That cancels it on the right, and that's what goes in my calculator. Negative 4.1 divided by 7.5, which is negative 0.547 meters per second per second. And make sure it makes sense. This does make sense. It tells us that he's moving forward at 4.1 and he's slowing down. So his acceleration does need to have the opposite sign, and it does. Because my initial velocity was positive, my acceleration does need to be negative so that the object will slow down. All right, so that's not the answer we're ultimately looking for, but it is the first step in finding it. Now we need to find force. Because I just found acceleration and because the question gives me mass, we can just use F equals ma and plug in our mass and our acceleration. Our mass, again, double check your units, but it's already in kilograms, so we're good. 93 times negative 0.547. When I multiply those, I get a force of negative 50.84 newtons. And again, that force will be in the opposite direction as the object's motion, and it is. Okay, negative. Questions about this example problem? Again, this is a 2-step problem. We did some yesterday that were 2, 3, 4 steps long. So it's a similar process. But I didn't actually write out, here's what I'm going to do for step 1, here's what I'm going to do for step 2. This is kind of more where you're going to be going with it. You're going to be able to just look at it, hopefully, and see, oh, I need to find acceleration before I can find this. If you need to write out those steps and say step 1, do this, step 2, do this, like we did yesterday, then by all means do that until you're comfortable enough with it to maybe skip that step. All right, let's look at another one. Follow-up question to this one, actually. It says, what is the change in momentum for the boy and the sled? So it's the same problem, but we're going to look for change in momentum. And I already know that anytime I'm looking for momentum, I'm looking for mass and velocity. I can get an initial momentum and a final momentum, and I can subtract final minus initial to get change, or I can do mass times my change in velocity. I do have two velocities and a mass, so I should be able to do this. But I'm going to use this approach. I'm going to look for a change in momentum being my final momentum minus my initial momentum. And when I look at the equations for each, it's just the momentum equation. My final momentum will be my mass times my final velocity. My initial momentum will be my mass times my initial momentum. I already know what my final momentum is, because look at my final velocity. It's 0, which means my final momentum is also 0. I'm not going to bother plugging in numbers to that. If I multiply by 0, it's 0. Okay, for my initial momentum, though, I do need to plug in some numbers. I need my mass, 93, and I need my initial velocity, 4.1. When I multiply 93 times 4.1, I get an initial momentum of positive 381.3 kilogram meters per second. But the question again asks for change in momentum. And my change in momentum is my final minus my initial. So it's not actually going to be positive 381.3 because my final was 0. This object is losing momentum. It's stopping. So when I look at the change, it's actually a negative number. 0 minus 381.3 is negative 381.3 kilogram meters per second. Make sure that you pay attention to the sign. Make sure it makes sense. If it says that the object is coming to a stop, then you need to think in your head, oh, my momentum, I'm losing momentum, so it needs to be a negative number. Questions about this one? All right, let's look at another one. This one says, Jamie tosses a 435-gram baseball straight up in the air. It takes 0.83 seconds to reach its max height. Find the ball's momentum immediately after the toss. So the other thing we can do that we did not do yesterday is we can incorporate some of these multi-step problems into free fall, because it's the same equations as the rest of our acceleration problems. So this one is a free fall scenario. So let's go ahead and label our given information. In the question, they tell us the mass of the ball is 435 grams, and they give us a time that it takes to reach max height. I do want you to be aware that that's just the time it takes to go up. The ball will come back down. If we're asked anything about its total range, we're going to need to keep that in the back of our minds. Okay, but time up is 0.83 seconds. I don't know if I need the total time or not yet. All right, so those are the only two numbers given to me in the question, but they are not the only things that we know. Because this is an object in free fall, anytime you have an object being thrown, we're going to deal with free fall, I know my acceleration. Every free fall problem has the same acceleration, negative 9.8 meters per second per second. It's not going to be in the question. You need to look at it and say, oh, this is free fall, I know my acceleration, and add it to your givens because it's not going to be listed. All right, so now I have another piece of information, A. That's still not enough for me to actually do anything with this. I need one more piece of information. What else do I know about this ball that has been tossed straight up?
Its final velocity is 0.
I know its final velocity, specifically at its highest point. And yes, it is 0. Okay, and so I know my final velocity at the top. Okay, that final velocity when it reaches its highest point is 0, because if you throw something up in the air, and you guys know this, okay, you've probably done it before, but you throw a ball straight up in the air, it's going to slow down until it stops, and then it's going to fall back down and it'll speed up again. But for just a split second, it has stopped because it's turning around. Okay, so that's a point we can use, especially since it gave us a time to get to that point. The time goes with that point also, 0.83 seconds to max height. So at max height, my velocity is 0. All right. I know I'm looking for the ball's momentum immediately after the toss. So I'm looking for the initial momentum, but momentum is mass times velocity. I can't find momentum unless I know the initial velocity. I know the mass, but I need the initial velocity. So I'm actually going to solve for VI first, and then for initial momentum. So finding VI, again, if we're looking for initial velocity, we really want to look at our kinematic equations. I have a time, I have an acceleration, and I have a final velocity. I can find initial velocity by using equation A, because equation A has the variables that I've labeled, VF, VI, A, and T. So that's what we're going to do. We're going to plug into this equation and see if we can solve for VI. Again, when you substitute in, check your units. These are all okay. I've got meters per second squared, and seconds. Everything's consistent. So I have 0 for my final velocity equals VI plus negative 9.8 times 0.83. From here, you're going to multiply that negative 9.8 and that 0.83 to get negative 8.134. And so you have 0 equals VI minus 8.134. Again, we're trying to solve for VI, so we need to add 8.134 to both sides, and that, of course, would be your initial velocity. 8.134 meters per second is the initial velocity of this ball. Again, the question doesn't ask for initial velocity, it asks for the momentum initially. So we're not done, but we did the first step. I already know I can't find momentum without velocity, so we needed to find that first. Now that we have the velocity, which I'll go ahead and add right here, now we can find momentum. Momentum is mass times velocity. Initial momentum is mass times initial velocity. We just found the initial velocity, and the mass is in the question. However, before I substitute in, I need to check my units, and there is a problem. Please don't plug in 435 grams. It's in grams. It can't be. It needs to be in kilograms. So before you can solve this, you have to first do a unit conversion. If you forget to check your units, you're not going to catch that and you're going to miss the problem. So make sure that you're looking for those things. All right. Again, there are 1,000 grams in a kilogram, so divide that by 1,000. 435 divided by 1,000 is 0.435, and I can multiply that by my velocity, 8.134. When those two numbers get multiplied, you get this initial momentum, 3.54 kilogram meters per second, and that is the answer to the question. That is the ball's momentum immediately after the toss. So based on its initial velocity, that is its initial momentum. Are there any questions about this problem? All right. Then I do have one more follow-up. Follow-up to it says calculate the force acting on the ball while it's in free fall. I only have one equation for force, F equals ma. Luckily for me, I already have m and a labeled. So I can just plug straight into it. Make sure that you're using the mass that we converted and not the one back from the question. Okay, we already converted it to kilograms. It's 0.435. Multiply that by negative 9.8, which is my acceleration for every object in free fall. And when I multiply those two values, I get this, negative 4.263 newtons. Anybody tell me why my force is negative? Why am I getting a negative number? It is falling, but why is the force negative? What force is causing this acceleration? Why is it going down? Gravity. Gravity always pulls things down toward the earth, so it's going to be a downward force. Okay, that's why you're getting a negative number. So again, check the sign, make sure it makes sense. But yes, gravity causes a negative acceleration of negative 9.8 because it applies a force downward on these objects. All right, negative 4.263 newtons in the case of the space ball. Any other questions about this problem? Again, those are just two more double multi-step problems that are similar to the type that we did yesterday, and you have more of them in your assignment today. For the rest of the period, you are working on either your RA, which is due by 11:59 p.m. tonight, or 202.4, which is yesterday's assignment, which is also due by 11:59 p.m. tonight. So whichever of those you need to work on, or maybe both, use your class time accordingly. You do have a quiz coming up on Friday of this week, and you have a unit test on Tuesday of next week. So you've got some tests, assessments coming up. There will be a MyOpen Math review in class tomorrow, so you will have a review assignment that you can use. However, if you're looking for review right now, maybe you're already finished with both your fan card RA and 202.4, then I did want to point out that there is a unit summary in Schoology. We posted it in there, and that is a really good review tool that you can use. It's also a CFU redo, so if one of your daily grades wasn't so hot, use the unit summary, and it can replace your daily grade up to a 70 as a redo. Other thing that's up here, as a reminder, I mentioned this a couple weeks ago, and we haven't talked about it again since, and I don't know if you remembered to look at it or not, so I'm reminding you today. There is an optional project for bonus points, basically. Optional rocket project, if you choose to do it, is due on October 8th. You still have a couple of weeks to work on this, about 3 weeks. So if you are wanting to do it, you've got time. As a reminder, that project will replace your lowest test grade for either Unit 2 or Unit 3. You do have to take the test first for it to be replaced, so don't think you can just skip a test. That's not how that's going to happen. Okay, you're still going to take it, but if you do choose to do the rocket project, it does potentially help you out a little bit in the event that your test doesn't go so hot. However, the primary reason we're doing it is more for the next unit, more so than this one. So hopefully you don't end up needing a redo or anything, but that's why it's there, because that Unit 3 test is on the last day of the marking period. So that is why that project is in there as a bonus. So if you're wanting to work on it, you can work on it alone or with one other person. It's either individual or in pairs, up to you. You can find it in Schoology. There's a purple folder that says bonus bump on it. Open it up, and there is a rocket project in there, and there's a project information sheet with all the details. Just as a heads up, it says this on the information sheet, but I'm going to say it right now as well. We will not accept this late. It's an extra credit assignment. So if you're absent the day it's due, hopefully you turned it in early, okay? Because it will not be taken late even if you're not here. We don't have to accept bonus points late. So heads up, I would recommend turning it in early, especially if you know you're going to be out, okay? But that, if you haven't looked at it yet, I would strongly encourage you to take a look and see if it's something that you want to do. So anyway, that's it for me today. The rest of the period, you guys are working on either your RA, on 202.4, or your unit summary, or maybe even taking a look at the rocket project. If you have questions as you're working, please let me know.